yesterday and a little bit the day before as well. For those of you that are continuing to have some form of struggle when it comes to using your graphing calculator and setting up the window settings so you can see the relevant features of the graph, today we'll see that you don't really need to rely on your graphing calculator. There's an algebraic approach to determining where the vertex is. And what we're going to be doing is spending today and tomorrow on that, which leaves Thursday and Monday after the long weekend for review and your unit exam. And I posted this in Google Classroom. Your unit exam is scheduled for Tuesday. Go ahead, fire away. 13? 14. The gymnast one? Okay. So we have a gymnast that's jumping on a trampoline. His height, let me write out this equation so we can see it a little bit better. His height as a function of time is negative 5t squared plus 10t plus 4. I mention this a lot in my other courses I teach, like even calculus class. Sometimes the function notation is important and sometimes it's not. We don't need to write h of t. All that h of t is saying is that the height is determined by the time, that's all. But h of t in and of itself is just height. So that's the formula. T represents the time in seconds since he left the trampoline. What is the maximum height? So here's a perfect example. I can't help but look at this and determine what the vertex is algebraically because it's so simple. However, in order for us to do this on our graphing calculator, we need to graph it. So I'm going to enter in for y. Negative 5. Well, I'm using x instead of t, but that shouldn't bother anybody. Plus 10t plus 4. I'm just going to double check to make sure that I have entered everything correctly and it looks fine. And I spent some time outside of class earlier today in the cafeteria with some students talking about how to set up the window settings. And I said, you know, a good thing that you can look at always is to go to your table setup, start at 0 and go up by 1. And as I was saying this to them, it occurred to me, I think you know this, but I never said it, that we're talking about x here. When I say start at 0 and go up by 1, I'm saying x is going to be 0 in the table and I go up by 1. And now if I go to my table, I get a flavor for what y is like. And right away I lucked out here. Because at 0, y is 4. And by the way, you should be able to look at this equation and know that y is 4 at the beginning because that's the h-intercept. Okay? But then it goes up to 9, and then it goes down to 4. And as soon as I see here that sometime after 2 seconds the height is negative, what that means is the function is no longer valid. The trampolinist has gone above the tramp and come down and landed on the trampoline sometime after 2 seconds. So what that tells me is the maximum is occurring somewhere between 0 and 2 seconds, roughly. So I'll keep that in mind, okay? I'm going to go 0 to 3 seconds in my window setting. What about y? Well, I can see there's a height of 9. I suspect that is going to be the maximum because it goes from 4 to 9 to 4. That 9 is halfway between there. But things are not always as they might appear. So I'm going to go up to, say, 12. My window settings then become 0 to, I'll go 3, even though I know that at 3 seconds the function ends for this trampolinist journey. And I'm going to go up to 12 for x. Is this in meters? Wow, okay. I say wow because I saw a height of 9. 9 meters is almost 30 feet. This person's really flying. And now, I think your question is answered now. That's how do we get here? Once we're here, we can go to the calculate menu, choose maximum, left boundary, I'm going to go 2. Wrong. Do that again. Left boundary, I'm going to go 1. Ooh, wrong. I'll try again. Left boundary, I'm going to go 0.8 seconds. There we go, it's to the left. Right boundary, I'm going to go 1.2 seconds. It's to the right. I suspect it's at 1 second, yeah. And it's 9 meters. So the answer to this question is the height is 9. Now, you don't know how to do it algebraically yet. You know, and I had mentioned that yesterday, that any of these questions right now, we're just stuck on using our graphing calculator. Is that okay, though? Okay. Other questions? Go ahead. Absolutely, and I'm glad you asked. Because this is not just like, oh, it's a challenge question. This is a question that you would expect to see on an exam. And the specifics of this question, content-wise, is it is about a quadratic function. I'm going to use y instead of f of x. It is about a quadratic function, so it's in this unit, okay? But the math involved is in any unit. What we have here are 2 missing parameters. And we've run into this in the first unit when you have 2 missing parameters. I don't think we ran into it in the trig unit, but in the first unit when you have 2 missing parameters, you need 2 equations. And since we know that this graph passes through -1, 6, if I put -1 in for x and 6 in for y, I get an equation relating b and c. And the graph also passes through 2, 3. So when I put those in for x and y respectively, I get a second equation. And this is what I meant at the beginning of the year when we introduced the concept of what is a parameter, that a missing parameter is always found the same way. Okay. And this is going to carry through into Math 30. So what will equation 1 be? I'm going to try to do a better job organizing the system of equations than sometimes I do. My first equation is going to be y, which is 6, equals 2 times -1 squared plus b times -1 plus c. And I'm going to work left to right here, even though I usually say just work down, because I want to keep equation 1 on one line and equation 2 on another line. I'm not going to say equals here, though, and I think this is really important. I'm going to do that. And I think when you have an equation with 2 unknowns, it's standard practice to put the unknowns on one side of the equation and put the numbers on the other. Now, this is the problem with working left to right here. This stuff, which is right here, is staying there, and I'm moving this other stuff to the left, but I'm writing it the other way around. I hope you understand that this will be 2. 6 minus 2 is 4. So I get 4 equals -b plus c. Just to avoid any confusion, I'm going to write it in that same way. I wanted to write -b plus c equals 4, but I could see some people bothered by that. Okay. I'm going to do the same thing for the second point. And incidentally, I believe question A here is done using this idea, but you just have one unknown. So now I'm going to get 3 coming out, and I'm going to put in for y 2. So what happens here? I end up with 2b plus c. And what do I have? I have 2 squared is 4 times the 2 beside it is 8. 3 minus the 8 gives me -5. And this is what I'm dealing with. A question for you. How many of you would solve that system of equations by rearranging one of the equations for a variable and putting the result into the other equation? Okay, not too many. And that's okay. If you want to do it that way, you can. I think it's simpler, well, for me, it's simpler to look at the fact that I have, well, I'll ask this question. How many of you would subtract the equations because you see that there's a c in each? How many of you would multiply one of the equations by -1 and then add them? See, that's what I would do. I mean, we could subtract, right? I could go 5 minus, pardon me, 4 minus negative 5 is 9. Negative b minus 2b is negative 3b, and c minus c is 0. Do you agree subtracting is more difficult than adding? I mean, it's marginally more difficult. It's not a big problem. But you're going to arrive at the same thing if you did this and just added them. Just to me, that's easier. Anyway, right now what we know is that b is negative 3, because when I divide both sides by negative 3, I get negative 3. So b is equal to negative 3. Now I just use whatever tools I have at my disposal to find out what c is. I'm just going to use 4 equals negative b. Oh, this is a little tricky. Negative b is negative negative 3 plus c. So I end up with 4 equals 3 plus c, and I'm pretty much done. Now I know c is equal to 1. Is that okay? Good. Any other questions before we get started here today? Go ahead. 9b. This one? Okay. So we have a quadratic function, determine the domain and range, and probably what you do is for A, and I know you asked about B, for A you say, well, any quadratic function is a parabola, and it will be x is any real number. And for the range, since this parabola opens down, it will be y is less than or equal to some number. And correct me if I'm wrong, that number is 68. Okay. But don't worry about how I did that. I did it using calculus, but that's not important because you're asking about b. You end up with y is less than or equal to 68. But if this function represents the height in feet of a football as a function of time, the fact of the matter is the height of a football is never negative. And neither is time ever negative. So I don't know what this looks like in relation to the axes, but I'm about to find out. Negative 16x squared plus 64x plus 4. I'm going to set my window to go from 0 to, I'm going to go 4 only because I've seen footballs kicked in the air, and generally speaking, they're not in the air for more than about 4 seconds. I'm also going to look at 0 to, well, this football's kicked at quite an angle because the maximum height is 68 meters, right? Or is it feet? It's feet. I'm going to go up to 75, and I'm just going to see what it looks like. So, wow, it's almost exactly 4 seconds. In order for me to talk about, and I'm not going to actually do this, you can do it on your own. But in order for me in B to talk about the range, well, the range is no longer this. This is the range. Because it goes from 0 at some point, it's on the ground at some point, whether it's at the end or the beginning, it doesn't matter. And the maximum is 68, but it can't be negative. And then for the time is going to be, is going to be 0 is less than or equal to x, which is less than or equal to whatever this is. Is it 4, by the way? See, in order for us to find that out, Alexa, we have to go back to our window settings, broaden our horizons horizontally. I'm going to go to 5. And also look below the time or x-axis so we can see that tail hanging over, so we can use the 0 function of our calculator, because we have to go left and right of that. So I take it back. I am going to do this 0. 3.5 for left and right. I'll just scroll. It's a little more than 4 seconds. That was total fluke that I said it's not in the air for more than about 4 seconds. So what we would say here is approximately 4.1. I've never really seen this done in print, but I do it anyway. I put a little dot above the inequality just to indicate that it's an approximate number coming up. I guess the point here is that there's a difference between looking at an equation or a graph just mathematically blindly with no context, and it has a certain meaning that we have in A, and then when we apply it to something, it has a different meaning. All right, we're going to move on now. So you're going to want to open up your books to 20.3.3, Completing the Square Part 1, which I believe is on page 15. All right, thank you. So we're looking on page 15 at completing the square. If you look at the objective here in the box on the screen, it says convert quadratic functions from standard to vertex form. That is completing the square. When you complete the square of a quadratic function, you're changing it from standard form, which is that useless form that we have to go to our calculator to analyze. It's not totally useless, but we're converting it from that form into the vertex form. And for that reason, sometimes the vertex form is called the completed square form. So a quick review of some things you should already know here. When a quadratic function is written as f of x equals a times x minus p quantity squared plus q, which is called the vertex form, there's some information that's just staring you right in the eyes. The vertex is at p comma q. You just look at those numbers. That's where the vertex is. The axis of symmetry is at x equals p. If a is negative, the parabola opens down. If a is positive, the parabola opens up. I don't have in here the whole discussion of maximum and minimum, but if a is negative, it opens down. There's a maximum if it opens down, and the maximum would be q. If a is positive, it opens up, and there's a minimum, and the minimum value of y would be q. And then, just for good measure, we throw in this, that a has to do with the stretch factor, which tells you how narrow or wide the parabola is in terms of y equals x squared. We often write them in this form, though, and we've learned this over the past couple days. Quadratic functions very often make their appearance to you like this, and this is called the standard form. It tells us very little about the graph, although I just make this point. Whatever a is in the standard form, it's a in the vertex form. You know, for example, if we go back to the question that Alexa asked about, which is this one here, where we started off with y equals, let me highlight it for you, where we started off with y equals negative 16x squared plus 64x plus 4. Although I can't tell by looking at that where the vertex is, I don't know what p is and I don't know what q is, I do know that a is negative 16. And if I could convert this to vertex form, a would still be negative 16. Okay? So, as a warm-up here, we're going to go back to grade 9 math and do some work. Simplify each binomial perfect square to express it in the form x squared plus bx plus c. So I want to make a point here. A binomial perfect square is a binomial that's squared. 16 is a perfect square because it's 4 squared. 25 is a perfect square because it's 5 squared. This thing that I've highlighted here in A is a perfect square because it's x plus 4 quantity squared. And I would like you to think, you don't have to say it verbally, but I would like you to think of it that way, x plus 4 quantity squared. it reminds you that you don't do anything wacky here, like square the x and square the 4. What it means is x plus 4 multiplied by x plus 4. So you have to simplify that by multiplying it out. And that gives us x squared plus 4x for my outer, plus 4x for my inner. We're all taught in Alberta, Canada, North America, this FOIL thing, first, outer, inner, last, so this should be no surprise to you. Plus 4 squared is 16. So you get x squared plus 8x plus 16. I'm sure I mentioned this yesterday. I'm sure it was yesterday, but I can't remember all the details of everything all the time. How many of you can go directly to this? What I would say to you is sooner or later, by the time you get to grade 12 certainly, you shouldn't need to write x squared plus 4x plus 4x plus 16. You should kind of be one step ahead in your head and saying that this will be 4x and this will be 4x, so that's going to be 8x. Okay? And sooner or later as well, you shouldn't need to write x plus 4x plus 4. So for example, when we do C, I'm going to go down to C, and I square x plus 5. You ought to be able to, at some point, simply say it's this. How many of you, whoops, how many of you are capable of handling that? Okay. If you need to write out x plus 5 times x plus 5 to get the right answer, regardless of how many steps you need to take personally, if you need to write that out, by all means write it out. When you FOIL this, you get plus 5x in the outer, plus 5x for the inner, plus 25. So our answer is right here. This is our answer to C. This is our answer to A. If I were to do the same thing here, if you need to right now write x minus 3 times x minus 3, you do it. I'm not going to do it this time. And you FOIL that out, you get x squared minus 3x plus 9. So we get x squared minus 6x plus 9. Capiche? If you need to write out x minus 12 times x minus 12, do it. If you need to then write x squared minus 12x plus 144, that's fine. I'm going to say that this is x squared minus 14x plus, not 14, minus 24x plus 144. So what's happening there is I'm taking, and you don't need to write this part down, I'm taking x minus 12 times x minus 12, I'm FOILing it out and collecting the terms. Are we okay with that? Okay. Any questions with that first part of the warm-up? Okay, now there's a question. And let me get rid of this. Let me get rid of this. The question is going to be asking about B and C. In our answer here for A, the value of the parameter B is 8. In B, the value of the parameter B is negative 6. In C, it's 10. In D, it's negative 24. So I want to just remind you, we're talking about y equals ax squared plus bx plus c. Right? So b is always going to be the coefficient in front of x. C is the number by itself. When you take a look at the number 2, it says, what do you notice about the relationship between B and C? So I'm going to go back here. B is highlighted in blue, and C is highlighted in yellow. And the question is, what's the relationship between the number in blue and the number in yellow? whatever the relationship between the number in blue and the number in yellow is in question A, it's the same relationship that those things have to each other in B. And that's the question I'm asking you right now. How are B and C connected? Yeah.
It takes the same number to make both of them. In one case you add the same number, but in the other case you square the other number.
Perfect. So one of them, they say, I'm going to pick on the 8 up here. That number is found by adding 4 plus 4, whereas 16 is found by multiplying 4 plus 4, 4 times 4. Here it's 5 plus 5 and 5 times 5. Here it's negative 3 plus negative 3. And here it's negative 3 times negative 3. Okay, perfect. Let me ask you a different question then. If you knew this middle number, but you didn't know the final number, let's say I told you that the result of squaring a binomial was x squared plus 14x plus, and I didn't tell you what this number was. Could you figure out what that number is? What would it be, Nate?
49.
Okay, now 49 is perfect, that's right. Can you explain to me how you know, well, before you do, what would be up here in the brackets?
7.
X plus 7, okay? Now, explain to me how you got 49.
I divided 14 by 2 and then squared that.
That's perfect, and that's the best thing to remember right now. What Nate said is he took 14b and he divided by 2 and then squared it. So if we go here and I take 8 divided by 2, that's 4. 4 squared is 16. Negative 6 divided by 2 is negative 3, squared is 9. 10 divided by 2 is 5, squared is 25. Negative 24 divided by 2 is negative 12, squared is 24. So the answer to this question is this. This is the relationship between B and C if it's a perfect square trinomial. And by the way, there's nothing wrong with saying x plus 3 quantity squared is a perfect square, but when we expand it out, it becomes a trinomial, doesn't it? It becomes x squared plus 6x plus 9. That's why we sometimes call these a perfect square trinomial. All right, so let's turn the page. We went through all of that to learn that this is the rule. So for example, I'm going to go off script here. Is this a perfect square trinomial? Is that a perfect square trinomial? No. Because half of 12 is 6, and when you square 6, you get 36, not 24. Is this a perfect square trinomial? I'm kind of sucking some of you into believing it is, but it isn't because it's minus 81. And when you take negative 18 divided by 2 to get negative 9 and square it, you get positive 81. Perfect square trinomials must always have a positive term at the end. That is now a perfect square trinomial. If you go back and look at all of these, all 4 of them, even though some of them had negative numbers in the binomial, and negative x's in the expanded form of it, they all end up with positive c's. Okay, again, I'm going off script here a little bit. If this is a perfect square trinomial, what number must C have for a value? Liberty, do you know? 100, perfect. If this is a perfect square trinomial, what was it before we squared it? All of these things I'm asking are things that you need to be able to figure out on the fly. Aoki, do you know? X minus 10. How do you know it's minus 10? Right. And this is really important. The number that's in here in the binomial, Aoki said, because negative 20 divided by 2 is negative 10. So to go from here to here, you divide by 2 and then square it. To go from here to here, you just divide by 2. All right. So what are we doing here? We're completing the square. When you go from a standard form, which is this thing on the left that I'm highlighting in yellow.
Brown.
Thanks. Who helped me out there? Thanks, Nate. I appreciate that. I thought that was yellow, but there we go. That thing that I'm highlighting in yellow is the standard form. If I change it to what's highlighted in green, I change it to the completed square or vertex form, and that process is called completing the square. If you go from the vertex form to the standard form, that's just expanding. There's no special name for it. So this is what we're going to learn. We're going to do 4 examples where we take something in standard form and complete the square so that you can tell me where the vertex is, what the axis of symmetry, all of that stuff is, without a calculator. So here's how you do it. We start off, I hope you're okay with me just saying y. Let's dispense with the fancy stuff and just call it y. Y equals x squared plus 10x plus 16. We're going to rewrite this, but you are going to move the 16 down the line. You're going to leave some room in between the x terms and the constant term. And just for a moment, a minute, you're going to ignore the 16. And you're going to say, what number would I add here to make this a perfect square? Trinomial. And I think I've set the stage for this. I think you know. Nate, 25. Half of 10 squared. Half of 10 is 5. You square that, you get 25. But let me ask you a question. Is this thing now that I've written, x squared plus 10x plus 25 plus 16, is that the same as the function that we started off with? No, it isn't. Well, we can do something to make it the same, and it's to do this. By adding 25 and then taking away 25, I haven't really added anything to it. But what I'm doing is I'm adding the 25 to the x terms to get a perfect square trinomial, and then I'm taking the 25 away elsewhere. And I think I've set the stage here. And Aoki, I'm going to ask you, because we just talked about this. This is a perfect square trinomial, which means it can be written as a binomial squared. What is it?
X plus 5.
Excellent. It's x plus 5 squared. Plus, well, not really plus. We've got some other stuff over here. You need to figure out what 16 minus 25 is, and that's negative 9 last I looked. Okay, so minus 9. Look at what we have. We've got a completed square form. We have y is equal to, just rewrite it without all the clutter, x plus 5 squared minus 9. We know where the vertex is. If I make a list here, everybody, of A, A is 1, which means this parabola opens upward and has the exact same shape as y equals x squared. It's not narrower, it's not wider. P is -5, and Q is -9. So if we wanted to sketch this graph, and I've given you a grid there, you don't need to sketch it. As far as I'm concerned right now, you should be able to tell me that this original function has a vertex at -5, -9. It has a minimum value of -9. The axis of symmetry is x equals -5. The range is y is greater than or equal to -9. Remember that little quiz you wrote a few days ago? All that stuff you can answer about this. But I'm going to sketch it. Not what I wanted to do. So, -5, -9 is the vertex. If y equals x squared looks like this, then this graph will have the exact same shape. Once again, I think it's obvious, but this graph is going to have the exact same shape because A is 1. This is y equals x squared. What are we asked to do here? Draw a rough sketch. That's good enough. We're not even asked about the domain and the range and the axis of symmetry and any of that, because we already know how to do that. Go ahead, Gabrielle. Because it's x plus 5. So we are comparing here. The question is, where does the -5 come from? And we are comparing our function here to this This is a 9 up here, right? Not a Q. So what number would we put in for P so that if we had x minus P, it would become x plus 5? Have I answered your question? Okay. So we're back to what we learned on, I think, the first day of the unit, that the number that is being added or subtracted from x, whatever the sign in there is, that's the opposite of what it is on P. So if it's x plus 5, P is -5. Any other questions with that one? Right? X squared minus 6x minus 20. So we make room for something that is going to be added to get a complete perfect square. This is why it's called completing the square. X squared minus 6x is not a complete perfect square. I need to add a number, and Paige, what number am I going to add? 9, perfect. And that means I have to take away 9. I'll do this in a different color. I add 9 there, I take away 9 there. If I've done a good job of this, it's not that difficult. Once you've got that, all you have to do is say, well, this will be x plus 3 squared. Is this right? What's wrong with it, Paige? Should be negative. Because it's half, just like Aoki said, it's half of b. Don't look at the 9 to decide whether it's positive or negative. Look at the b. And I will be honest, that wasn't a test. I accidentally thought plus, and then I looked and saw it should be minus. That was a legitimate mistake on my part. And then minus 29. Ooh, okay. Well, this parabola will have a vertex at P comma Q, which is 3 comma negative 29, just someplace over here in quadrant 4. The value of A is 1, so if this is y equals x squared, then this function that we are drawing will have the same shape to it and open up. So, I'm going to move that before I really hurt myself. Again, if I wanted you to determine the axis of symmetry, the domain, the range, all that business, you could do it. But we're not going to spend class time doing it because we've done it a dozen times already. Uh-oh. Something's different here. What's different is A is not 1. And when you look, just forget about this specific question. When you look at our goal is this, isn't it? But if I were to expand that out, it would be that. And if I were to continue expanding that out, it's going to require a little bit of thought on your part, but do you agree that if I FOIL out x minus p times x minus p, I get this perfect square trinomial? Okay, well, what's important is the perfect square trinomial, this is the perfect square trinomial that we build by adding a number, right? We build that by adding a number. But that perfect square trinomial has a coefficient of 1. This rule we've learned that you take half of b and square it to get c only works if the coefficient of x squared is 1. So we got to make sure that it's a 1 in front of the x squared. Now, how do we do that? I mean, you can't just do this, right? You can't just say, well, let's make it 1. And I know I'm being a little facetious here, but you'd be surprised at how some students think. Sometimes they go, well, we have to make it 1. That's not how you make it 1. Does anybody have any ideas on how I can change that 3 to a 1? And there could be, well, anyway, go on. Yeah.
Divide the coefficient beside the x squared and the minus 18 by 3.
Okay, so I want to make sure that I understand what you're saying, and I want to make sure that I don't create some misconceptions here. If what you're saying is this, the answer is no, that's not what we do. We can't do that. Is this thing that I've written the same as what I started off with? No, I can't do that. We're on the right track, though. We are. Any other ideas?
We divide both sides of the equation by 2.
Okay, we can. And if we do that, okay, if we do that, I'm going to have, give me a second, I'm going to have y over 3 equals x squared minus 6x plus 20 over 3. And although this will work, 1, it's introduced some fractions, and 2, I don't want y over 3, I want y. And you could certainly do this, and then when you're done over here, multiply by 3 to bring that 3 back over. But you're still dealing with fractions. So this is better, and it will work, but it's not what we're going to do. Is there something we can do here to change the coefficient of x squared to 1 without dividing both sides by 3?
Maybe factor the 3 out of the first 2 terms?
Right. And I like that what you said. Factor the 3 out of the first 2 terms. We're still going to do this. Look, we're still going to do plus 20. We're not going to use the 20 with the x's and the x squareds. And we're going to factor a 3 out. And then we're going to worry about adding something. And I hope you see that that 3 that we factored out is about to become the a in front of the perfect square. No, we're not done. There's another twist here. Question? No? Okay. What do we add? Well, that's easy. I mean, sooner or later, you just get so used to this. Take half of negative 6, it gives you negative 3. Square it gives you 9. Good. What do we take away? It's not 9, because we didn't add 9. Let me repeat that, and I have not lost my brain. We did not add 9. What did we add, Jay?
27.
We added 27 because we wrote plus 9, but the fact of the matter is there's a 3 in front. So when we wrote plus 9, we've really written or added mathematically 27. This is what's happened here. So we have to take away 27. And now we can write it in completed square form. Y equals, I want to do this with some highlighting here, just to make sure you understand. We're going to have y equals a, which is 3, then we have x minus 3 squared, and then we have minus 7. The 3 is the a. The x squared minus 6x plus 9 is the x minus p squared, right? Just in factored form. And then the 20 minus the 27 is the q. So this is a parabola whose vertex is at, I can erase this, I think. This is a parabola whose vertex is at p comma q, which would be 3 comma negative 7. It opens up because a is positive 3, and it's considerably narrower than y equals x squared. So if this is y equals x squared, we're going to have it at 3 negative 7, and it's narrower. And again, we don't like to get into it in this course at this point, how much narrower or what the scale is. We'll worry about that in 30-1. Any questions with that one? I think we have one more. All right, same thing as before. You can only worry about adding that mystery number if you have 1x squared plus bx. You cannot add that number until you have 1 in front of the x squared. Because again, that perfect square trinomial has to be x minus a number squared. And the only way to have x minus something squared is to have x squared when you FOIL it out. So we have to factor out that negative 2. Y equals, well, I just prefer this first. I really do. There's always the odd student who, if I leave that 4 over there, they get confused with it. I leave some room. I'm not adding anything yet. I take out the negative 2. A common thing here is people go, well, shouldn't we take out negative 2x? You can, but then you don't have a quadratic left over to complete the square of. This becomes positive 8x. Negative 2 times positive 8 takes me back to the negative 16. I'm going to add something here. I'm going to close the brackets and put plus 4 here. So what number do I add inside of the brackets? Well, half of 8 is 4. 4 squared is 16. I add 16. Now, I have added 16 in the brackets, but I have not actually added 16 to that side of the equation. I've actually subtracted 32. I always need to look back to multiplying what I wrote in front what I factored out, by what I wrote inside, what I have left over. And by the way, just bear with me. If I were to multiply this out right now, do you agree I would get negative 2x squared? Yeah. Do you agree I would get negative 16x? Do you agree this is the 4 up top? What else would I get? Negative 32. So I've quote, added negative 32. I have to do the opposite over here. Now we can write it in completed square form. That negative 2 is our a. This will be a perfect square trinomial. In factored form, it will be x plus half of b. And then what do we have, plus 36? All right. So the vertex is at negative 4, comma 36. It opens down because a is negative 2, and it's somewhat narrower than x squared. Negative 4, 36 opens down narrow. Let's go back. Let's explore something from earlier today. We're trying to find the height here. Maximum height. Let's complete the square of this. You don't have to on paper. Just follow along up here. I have to take the negative 5 out of the first two terms and nudge the 4 out of the way. Does that look okay? What number am I going to add inside of the brackets? Christy, what number am I going to add in there? It would just be 1. Half of negative 2 is negative 1 squared is 1. What am I going to do over here for an adjustment?
Would it be negative 5?
Be positive 5. Because when you multiply these two things together, that's a 5. You get negative 5, and you have to do the opposite. Well, there's the maximum height, 9. Right, Q. When we did this problem, we had to poke around on our calculator to find the right window settings. And what we discovered, I should have saved the calculator window. We discovered that at 1, 9, the vertex was there. Well, P is 1 and Q is 9. I want to do one more question here with you. And I can't seem to find it now. I bet you it's here. Yeah, this is 13. There were a few of you in the cafeteria this morning I was helping with number 13, right? You want to find the maximum or minimum, complete the square. Let me do this. C equals 75n squared minus 1800n plus the 60,000. What do we have to do here before we add a number? Nate. Good. C equals 75 n squared minus 150, 304, I don't know, 300? No. It's not 300, no. 24?
Yeah.
Plus our mystery number, plus 60,000. What number are we going to add there? 144. Half of negative 24 is negative 12. Squared is 144. What number are we going to take away out here? Well, whatever 75 times 144 is. I can't do that. My brain is just, it's locking up right now. It's saying I don't want to do that.
10,800.
Who's got it? Paige?
10,800.
100800. Okay. So, in completed square form, is that right? Who was in the cafeteria this morning? You were there, right? This was the vertex. The vertex was at 12, 49,200. We had to produce 12,000 items to get that minimum cost. And it was a complicated thing finding the right window settings. This, as long as you're careful, the algebra doesn't lie. You don't have to worry about poking around in your calculator. So this is all now about completing the square. And what this means, everybody, is that from now on, you're expected to be able to find coordinates of vertices for parabolas and solve max-min problems for parabolas algebraically. Good written response question. Determine the maximum, whatever. Determine the minimum, whatever. So you have about between 15 and 20 minutes left here to work on these, number 2, 3, 4, and 6.